On March 18, astronauts Sunita Williams and Butch Wilmore returned from the International Space Station after the unscheduled 9-month stay in orbit. There has been much concern expressed around Williams and Wilmore's health, having survived the harsh conditions of outer space. Yet if anything, the duo had come out younger than we did in the interim period, thanks to strange physics that we typically do not encounter daily. Orbiting Earth at an altitude of 450 kilometers above the surface, Einstein's theory of relativity comes to play, slowing down time for the astronauts. One of the hallmark phenomena in Einstein's general theory of relativity, published in 1915, was gravitational time dilation. Time passes slower under gravitational field. Bizarre as though it may seem to be, experiments have proven the subtle but measurable effect. Stronger the gravity, the slower that a person's biological clock ticks. On Earth, people would have aged fractionally more than the astronauts. As a result, the astronauts spending time up in space should have aged faster due to gravitational time dilation alone, except that the duo aged slower. Time dilation, at its fundamental, is tied to how matter and energy warp space and time. Imagine a thin fabric of material. Mass and energy are akin to heavy objects, producing depressions in them. That depression affects not just any tiny object pulled into its space, but it also affects time. When the ISS zips through low Earth orbit, it registers speeds up to 28,800 kilometers per hour, or that's 8 kilometers per second. That is faster than a typical intercontinental ballistic missile when it is midway through its journey. At such tremendous speeds, time itself clocks slower for the ISS occupants. And during the journey, the lag outsizes the contribution from Earth's gravity. So in effect, the duo aged slower by approximately 0.0075 seconds. That's so small that virtually you might even notice there's no difference. But with a good atomic clock, though, time dilation can be demonstrated as a subtle yet measurable effect. In fact, engineers have already exploited this effect for half a century and more to solve technical problems arising with the Global Positioning System or GPS satellites to coordinate and ensure positional accuracy. The high-precision atomic clocks on board GPS satellites help software correct for latency errors, accounting for time dilation as well. Einstein had once said, the distinction between the past, present and future is only a stubbornly persistent illusion. Turns out he was right than we had ever imagined. Thanks for listening. This is physics where even time can bend.